Welcome back to day 5 of our first section of Unit 2. All right, today we're going to be looking at how I actually answer my question of how do I compare to my students' heights. So now that I've modeled how to visualize, quantify, and describe the distributions of heights and inches of the students in my Fall 2021 and Fall 2017 AP Statistics classes, it's time to explore how to answer my original question. Are my seniors getting taller in comparison to my own height of 65 inches? I'm about 5 foot 5 inches. All right, so for this part of our exploration, I'm going to demonstrate how to use percentiles and z-scores to quantify how my height ranks compared to the heights of my students in each year respectively. All right, so how to calculate and interpret percentiles. All right, a percentile describes the percent of observations in the distribution that are less than a specific value. All right, to calculate a percentile, count the number of observations that are less than the value you want to rank and divide by the total number of observations in the distribution. Now remember, an observation is one of the responses you had to your survey. All right, so they're your data points. All right, it helps to list the data from least to greatest and or to use a dot plot to avoid errors while counting. All right, so in our example, using the dot plots provided below, we're going to calculate the percentile of my height of 65 inches within each class respectively. All right, and then we're going to answer whether or not our calculations provide any evidence to help answer my question. All right, so in Fall 2021, when we look at 65 inches, all right, 65 inches is right about here, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 students. All right, so the proportion of heights less than 65 inches is 16 out of, let's see, that was 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. We had 34 total students. All right, so if we divide this, oops, sorry, I was a little bit out of frame there. All right, so the 16 was how many students are below my height of 65 out of 34 students total. So 16 divided by 34 puts me at 0.47 approximately, which if you multiply this by 100, this puts me in the 47th percentile. All right. Now 65 was actually the median value for this, so we could also argue that's the 50th percentile by looking at my value potentially being in the middle and taking one of these 65s on either side. All right. It could be calculated either way. We're going to stick with the strictly less than interpretation for this, which means that our interpretation is that 47% of AP, need to capitalize statistics, of AP statistics students in fall of 2021 were shorter than my height of 65 inches. All right. Let's take a look at 2017. All right. Now, first I'm going to count the total because I don't remember exactly how many students I had in this in that year. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. All right, so it looks like I had 45 students in that year. Just double check one more time. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 1, 42, 43, 44, 45. Yep, got 45 both times, so I'm pretty confident. All right, so the proportion of observations that were less than 65 in this year is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 26 out of 45. And if we divide that, 26 divided by 45, puts us at about 0.58. So I was in the 58th percentile. In that year. That means that 58% of AP Statistics students in fall of 2017 were shorter than my height of 65 inches. Interesting. So, do our calculations provide any evidence to help answer my question? I would say that they do. In 2021, a lower percent of students were shorter than my height. In 2017, a higher percentage of students were shorter than my height. And interestingly enough, when I would be speaking to my students, I would have to look up when speaking to less than half of them, whereas over here, I would have to look up when speaking to half or more of them. So, yes, they do. Let's see. So less than half of the students were shorter than 65 inches in fall 2021 compared to 58% of students shorter than 65 inches in fall, out of frame, 2017. All right, so that provides some evidence that what I was observing intuitively could actually be true. All right, so this is one way to do the comparison. All right, please pause the screen if you need to write this down. Let's take a look at our other way. All right, how to calculate and interpret z-scores. All right, a z-score, also known as a standardized score, describes how many standard deviations from the mean an observation falls, and in what direction. Now remember, standard deviation calculates how far the data points fall from the mean on average. Therefore, a z-score tells you how many average deviations a specific observation falls from the mean. All right, so the farther a z-score is from 0, the greater its difference from the mean of the distribution. If the z-score is negative, the observation falls below the mean. A positive z-score indicates that the observation we are ranking falls above the mean. To calculate the z-score, we calculate the observation minus the mean and then divide that difference by the standard deviation of the distribution. All right, so data point minus the mean, we had been using x bar for our mean, but population mean is often, we use the symbol mu, a Greek letter. We also tend to use s sub x when we're dealing with samples. For standard deviation, we use lowercase sigma another Greek letter to signify the population standard deviation. All right, so using the table provided below, we are going to calculate and interpret the z-score for my height of 65 inches in each year respectively. All right, so fall 2021, my z-score is going to equal my height of 65 minus the mean. Fall 2021 was 65.03. And then divided by a standard deviation of 3.38. Now, you can do this two ways. You could use alpha and then y equals to get the fraction to pop up. And then you can type everything in as it appears. So 65 minus 65.03. Use the down arrow to go down to the denominator, 3.38, hit enter, and we have negative 0.009 approximately. Another way that you can do this is that you can complete the subtraction first, 65 minus 65.03, and then divide by 3.38. If you still want to type it all together, but you don't remember how to find the fraction, put parentheses around the numerator. When you use the fraction feature, you are basically including an order of operation because you have to complete the numerator and the denominator separately before you complete the division the fraction represents. All right, so if you want to type it in this way, don't forget the parentheses around your numerator to keep it together to complete the subtraction before the division. Otherwise, PEMDAS is going to take over and it'll do it out of order. All right. Now, what does this mean? It means that my height, now you guys would be writing Miss Sanders' height. I'm going to write my height because I don't like talking about myself in the third person. My height is 0.009 standard deviations. Hold on one second. Oop, I'm misspelling that horribly. Deviations, there we go. Deviations below the mean of 65.03 inches. All right, it's below the mean because it's negative. All right, remember this says how many standard deviations above or below the mean we are. My z-score in 2017, again, my height of 65 inches minus the mean from 2017, 64.87, divided by 4.04. I'm going to use alpha y equals 65 minus 64.87 divided by 4.04. All right, so about positive 0.032. My height is 0.032 standard deviations above the mean of 64.87 inches. And again, do our calculations provide any evidence to help answer my question? So yes, let me clean that up a little bit. The positive z-score, sorry, I'm breaking lead left and right. Positive z-score in 2017 shows that my height was above average by 0.032 standard deviations. I'm going to abbreviate standard deviations as SD and then lowercase s. While the negative z-score in 2021 shows that my height was 0.009 standard deviations below average. Remember, the average is the mean. Now, during class tomorrow, you're going to calculate your own percentile and z-score for each of the distributions generated by your survey results. I'd like for you to compare with your seat partner to identify who ranks higher in each distribution. All right, we'll see you in class.